Hello, everyone, and welcome to the Security World stage of the CyberWise Con. Thrilled to be here as your host today. You'll be joining me for the first half of today as I get to introduce and listen to and participate with some of our wonderful speakers. Speaking of wonderful speakers, we have a fantastic first speaker lined up today. I'm joined here by Florian Rappl. Now, Dr. Florian Rappl is a solutions architect from Germany. He's joining us from Munich. Welcome, Florian. It's fantastic to have you here this morning with us.
Thanks for the kind words.
Well, Florian's going to be talking about micro front ends and security. So without further ado, Florian, I'm going to get off this stage and because really no one's here to listen to me today, but I'm going to hand it over to you. I wish you all the best. And please, just a reminder to the audience to ask questions in the chat. I'll be hosting a question session at the end with Florian. So here's your opportunity to ask Dr. Florian any of your burning questions. So Florian, I'll leave it over to you.
Thanks a lot. So welcome everyone. I wish you all a very nice conference. I'm here to kick it off. Just a few more words about my person. As already said, my name is Florian Rappl. I'm working as a solution architect for a smaller company in the Munich area called Smapiot. As the name might already ring, there's 3 letters in there, IoT, and there may be other combinations in there that might seem familiar, like API. We are doing mostly scalable API development in the IoT space, but I'm specialized in the creation of, scalable web applications, mostly in a distributed way, hence micro frontend. So that explains already one part of the title. We are also doing consulting in other areas, so some of these areas are shown here. If anything in there sounds interesting to you, always feel free to get in touch with me, for instance, via LinkedIn. But enough about me, so let's just dive right into the topic. And the first thing I want to note is that I've written a book about micro frontends, and even though security wasn't, let's say, a chapter of this book, right now I'm writing the 2nd edition, and there will be a dedicated chapter even on micro frontends and security. So essentially what we are talking about today. But even if you just have the 1st edition, you will already know that some parts in there, they are not, let's say, without security. It's already, let's say, sparkled all over the place. Just with the new edition, that will be also condensed in a dedicated chapter. And this new edition will be out, let's say, in 2 to 3 months, how the technical and the bureaucratic processes now go. But writing is finished, and now we are giving it the final touch. And so 2nd edition will be out soon. Now, you might say, security micro frontends, is that different from security in general of web applications? And of course, the answer would be no. I mean, micro frontend is still a web application. So if you have your OWASP top 10 open somewhere and you look at this list, this is a list of threats that also will, of course, appear or should be mitigated in a micro frontend solution, right? So it's no different in that aspect. However, of course, certain problems will occur more often in the micro frontend space, and we are here to look specifically at those problems. So the list here, OWASP top 10, was taken from 2021. I think they're releasing a new list about every 4 or 5 years, so a new one will come out soon, I guess. But make no mistake, I mean, independent how old these lists are, you could also look at an older version of it. Most of these problems are still relevant, and you should always account for it. Now, I've already asked the question, why talk about micro frontends specifically? Let's look at, let's say, the starting diagram of micro frontends, and this is the diagram taken from Martin Fowler's entry, I think, in 2017, where I think also that the name of micro frontends have been coined. So what do we see and what do we recognize here? So micro frontends is all about having distributed code getting essentially put together in a composition at runtime. So this is what is marked here as production. This means at runtime. Now, this simple diagram, of course, doesn't tell you anything about is this composed on the client, so meaning in the web browser, maybe on the server, is it on a single server, is it via multiple servers? All these technical aspects, they're not there. And that's, of course, for a reason, because like microservices, it doesn't put you into any constraints what the technical aspects of it are. At its core, micro-frontends is an organizational pattern, which means that it's all about having the ability in different teams to work together, even though you all have separate, let's say, technical repositories and all that. Completely isolated teams, they run their own pipelines, they decide on their own when to publish, and then it just goes into some artifact, which is marked here in the production column. And later on, at some stage, again, may be at the client, at the server, may even be an additional build step. So already, let's say, a build time composed solution. These different fragments come together and they form one page, or let's say your solution, your web application out there. But if you look already at it, it's quite unique from the point of view that you have certain things, like for instance, distributed code, meaning you have now parts in your application that you can't control, right? Because you might be now this team orange, but you don't control what team green and team purple here is doing, right? So you can't tell them how they should, let's say, scan their code statically, or how they should build or test the code. Of course, in some in-house micro-frontend solutions, which are the most things we are consulting it, you quite often you have some leverage there, and you can make some guidelines and even enforce these guidelines. So there is some leverage here, but make no mistake, in general, you will be in the position that you can't control what's entering there. And that puts you, of course, already at risk. And the risk only gets, of course, larger if you look how it then comes together. Because, for instance, if you take as an example a composition in the browser, you will now add scripts of teams that you may know, but you don't control the code, into your code base. And there might be anything happening to the scripts along the way. You just trust that these scripts now give you something. And you might now say, hey, wait a minute, I'm using, I don't know, some tool. Let's say I'm using Webpack Model Federation, so I don't insert in the scripts, but I mean, this is exactly what this tool is doing under the hood. So even though you are not doing it by hand, the tool is now doing it for you, and it is still doing the same thing. It's entering now from some remote URL a script source, and it just embeds it there. And this means you are in trouble, essentially. Because after all, when the script is inserted, code is executed. And that's now executed in this composition layer, which is, again, might be in the browser, but it might also be on the server, which puts you at even more risk, because, of course, in the browser, it's not nice. If the script goes rogue, it might install a keylogger or something, or maybe even get some tokens, whatever your architecture looks like. But on the server, it could get all kinds of access, right? For instance, to your database or other systems that you don't want, of course, to be compromised. And therefore, this presents quite a huge attack vector, and you need at all costs to guard that, right? So looking back at the OWASP top 10, which are the ones where, of course, with micro frontends, you open them up explicitly, potentially, and you need to have extra care. The number one is, in my opinion, injections in general, because now you want to have injection. After all, that's what micro frontends is about. But of course, you don't want to inject something you don't want to have in there. You only want to inject the code that you think is trustable, right? Of course, insecure design is something that strikes also in micro frontends, especially with the injection vulnerability that we've seen beforehand and that we talked about. So insecure design, you need to mitigate from the beginning. You really need to make sure that your design is under all conditions just rock solid, as good as it can be. Then we also have security misconfigurations. We will also talk about this a bit. And make no mistake, I mean, security is always, I would say, very hard to get right, because The thing is, you always think it is secure unless someone comes and says it's not, because I can construct the following thing. And then, of course, it's up to you again to evaluate that and say, hey, how likely is it to happen? And if it happens, what can be then the worst outcome? So you need to rate that at the end. And quite often, of course, companies, at least that we are consulting, they're getting external help for that, external penetration tests, etc. And then such misconfigurations can be, let's say, reported and properly fixed. But fixing it and seeing it yourself is always very difficult, because you are already in the forest and you just see trees there. For you, it's very hard to get the big picture after you designed the system. So yeah, a little bit of a chicken egg problem here. And finally, authentication flaws. This is something I always point out, because there are multiple ways how you can handle, let's say, authentication in your micro frontends. And I mean, there's, of course, just from the ground up, there is no really wrong way. But in my opinion, there are ways which are, given the resources, more secure and maybe even more convenient to deal with. And we look at what we can do here to actually, well, improve the situation. All right, so with that in mind, let's start with the authentication flaws here, because yeah, it's an easy thing to crack in the beginning. So what we want to look at is an attack vector where we say, okay, you start with the assumption that we use a JWT, for instance, and as a bearer token. And each microfrontend that wants to communicate with corresponding services uses this authentication token here, right? And we need to send it, of course, with a request. Now, you might say, what could go wrong here? I mean, come on, it's a token. But still, I mean, now you give this token away to the scripts, of course, that form the micro frontends. And these scripts, they might not behave so nicely. So even if they behave nicely, they could be flawed. For instance, a script could, instead of sending it to your backend, have a typo in there and sending it somewhere else. Now, since you just have a header, it will happily send it. And essentially, the following is happening. You have now the composition as remarked from the diagram earlier. Your orange micro frontend wants to communicate, maybe its own micro service. It sends the token, gets the response, all fine. The same goes for the green team. They send it to the backend API, all fine. And then for some reason, it might be that, I don't know, there was a misconfiguration. It might also be a typo that, I don't know, went untested in this specific area. The token can now be sent from the purple microfront to not the backend that it should be sent, but maybe to some malicious site. Could also be other reasons, of course. Code could have been hijacked. We come to mitigations of that later. But rest assured, we're just sending that token. And that token is a powerful thing. Until it expires, well, it does everything on behalf of that user. Not very nice. So what could we do here? Well, instead, the simplest way would be to not use any token. With that, we are not, let's say, in any danger to do something wrong. Now, of course, the question is, how can we now really claim that this is a certain user sending the request? Well, we fall back to the mechanism of the browser. We use session cookies. There are several advantages. The browser keeps track of them, so in a secure storage, most hopefully, and therefore they're essentially, well, not easy to grab. And we can make them HTTP only, meaning that, sure, you can't even read them out from JavaScript. So even if scripts go rogue, no chance to get access to them. And we can make them secure only. So even if there is some attack vector where the TLS channel or something would be circumvented, well, we wouldn't use or send the cookie, right? The browser takes care of all of that. And we can even then restrict it to, for instance, just our top level domain and not worry about anything regarding sending it from another domain or something. So with the domain policies, same site, for instance, we are always then on the safe side here. And that would be quite nice to just well, leave it all to the browser. There are other convenience points, in my opinion, that make this appealing. So for instance, since you don't have a token anymore, you don't need to worry about the token's lifetime. Sure, you might say, now I need to worry about the session cookie's lifetime, but then you could expand much further and you could control much further. And so there is one problem out of your way. Still, you might want to have access tokens, just not in your browser. So what you could do, as an example, is you could communicate now with a central gateway. Anyway, makes sense. And since this gateway sits maybe on the same domain, or at least on a subdomain, but within a space that you say within the cookies I can control, that it still sends there. The cookie would be sent from the browser implicitly to this gateway. And then from the gateway, the actual request is dispatched and the gateway just exchanges the cookie to the token if a token is available. The gateway also therefore makes sure that, I don't know, tokens are refreshed, etc. So it wouldn't use something like the implicit flow there. You could use something else. And therefore, I mean, it would also have access to a refresh token in the gateway. But nevertheless, however you implement it, in my opinion, it makes sense that the APIs themselves, they use a token, because this way they are rather autonomous, independently working, right? So they really, they just need a public key, for instance, and they can verify that this is indeed a valid authentication mechanism, a valid token, and they don't need to worry about the rest of the system. They don't need an auth service or a session service where they go to and then grab the information about the cookie, or I don't know. So that makes sense. And then again, if we now have this case that we described before and that we go to a wrong URL, I mean, the browser wouldn't send the cookie, so it only sends it if it matches. So the malicious side now gets no additional information, and we are good. We mitigated this, and we are fine here. Now, just to put it also a little bit into code, originally, let's say we had a request like this, maybe even with a full URL, and we sent the bearer token that we, of course, verified to be still up to date. Otherwise, we refreshed it beforehand. And now we transform this call and we say, okay, let's just go to, I don't know, /API that gets automatically dispatched to our gateway. And then the first segment here after API that points where it should then redirect to internally. And then we just have for instance, some convention, the actual endpoint. But if we put a put or, I don't know, post, etc., that just gets proxy. And we use this kind of proxy there, the gateway, to actually dispatch that accordingly. So quite nice. And as said, in my opinion, also quite convenient, because also now in local development, I also just need to always call /API, and then my local host can actually either forward it to some environment that I want to use as a backend environment for local development, or maybe already handle it locally and really mock the data, really then stressing out that local development should be as fast and maybe offline possible as possible, right? This is in my opinion, therefore, a win on multiple sides. So the only loss here is that now our infrastructure gets more complicated. But in my opinion, only slightly, and the advantage of more convenience and especially more security. Coming to the next thing, insecure design, what attack vector could we construct here? So as an example, and I mean, most of these are, of course, targeted in this direction. Let's suppose we have a man-in-the-middle attack here, such that we introduce additional code into a script, right? So as said already, we are injecting scripts, and in the front end, there's not much we can do because we want to inject these scripts. But still, of course, there are certain things we can do to control what these scripts can do, and especially, of course, how we verify that these scripts may not be tempted after all, right? So now let's say we have this man in middle tag, and it manipulates the source code of the script that needs to be injected, and it could, for instance, therefore put in a keylog or something else in there. So quite bad. And what can we do? How does the situation look like? So we grab these scripts, and instead of our standard JSON our standard JavaScript that enters in the orange and green microfrontend, we are now, for this script of the purple one, we are entering a modified script. Now, in my opinion, there are multiple ways to solve it. The most complex one is a certain kind of code signing, and we would need to evaluate using a special loader. You could use system.js, for instance, in the front end, and really make sure that there is some public key being satisfied here, so that you know a private key was used and signed the code. But I mean, after all, the only thing we are after is that we really verify that it wasn't, let's say, altered from when the team, let's say the purple team in this example, published the microfrontend or the script specifically to when we want to include it, right? And for this, it's enough to use a simple integrity check. And the beauty of it is that this is already fully embedded into the browser. Now, how does this look then in practice? What can we do here? One example is that if we use the sub-resource integrity and we want to use this integrity check, we use a central service, which anyway makes sense for micro frontends, in my opinion, in general. So this should be the service where the microfrontends are published. This is quite often known as a microfront discovery service. We quite often call it a feed service, independent how you call it. It's the one service where your teams publish their microfrontends to. It will put them the assets on a CDN and whatnot. And now this service, of course, can make certain computations. So for instance, around the script, it can compute the integrity of it, right? And now, if we ask the microfront discovery service, hey, give me all the available microfrontends, it would respond with something that looks, I have it here, so sorry, I need to swap those. It would respond with something like this. So it says, hey, there is a microfrontend in there. Let's name it my microfrontend. It's currently published in version 1.0.0. And this is the link for it, right? So this is the URL where the script sits. And now it also gives you this integrity property. This property we can now use on a script tag. So like this here, right? Such that, nice, now the browser knows the integrity. And if the script from this source loads and doesn't fulfill the integrity, which here is computed with a SHA 384, then, well, it won't allow running it at all. So before even evaluating the script, after it was downloaded, the integrity is computed and is verified against this attribute. This sub-resource integrity, it works not only for scripts, it can also be used for other things like style sheets. And in my opinion, it is a huge benefit, because this is one way how you can make sure that your assets have not been tampered. But of course, again, you shouldn't, let's say, before you request that resource from there computed, it should be already statically placed. So once you publish it, you place it there in your database, you write the integrity, and now, of course, you give it to the front end to verify that. So it's important that these two time positions are different, because, again, if someone gains access to, for instance, the CDN or the blob storage behind it and is able to modify the script, I mean, if you would compute it on the fly, you would get the same answer, and it wouldn't protect you, of course, that it wasn't, let's say, modified from the point in time where it was published to now. So this is what you really want to guarantee, and therefore you should compute it when it was published, and you should then therefore, of course, provide this value. Now, also looking at the diagram, how does it now behave? So before we even start loading this JavaScript, we go to our microfrontend discovery service. We get back the available microfrontends and the integrity attributes. And now we load them via their integrities. And so the purple microfrontend, it would be blocked by the browser. It wouldn't even be there, because the browser sees it doesn't match what was given. And that's the end of that story, right? So in my opinion, quite an easy fix, but it always involves, of course, that you don't directly put it in there. So if you use, I don't know, I again use as a reference Webpack Modi Federation, this doesn't work with this because it directly, you out of the box, if you use it like the simple examples suggest, you would not be able to put in integrity because you don't know, you just specify URLs there. So what you would need to do is Webpack Modi Federation, you would need to first go to discovery service and then, of course, request your scripts, but request them with the integrity flag. But then it would just work as it should. All right. Next point is injection. And as already said, injection is one of these fundamental aspects of a microfrontend solution, because after all, what you want to do is you want to inject certain things, right? So you want that runtime to compose it. Now in the browser, besides the things that we already covered, there isn't much you can do because, I mean, the browser, it just opens you one JavaScript runtime. If you want to open another one, you have just a few options. You can use an iframe, but then, I mean, everything happens on the iframe, rendering and everything, and that has other advantages and disadvantages. In general, you don't want that for a solution that really nicely composes on the screen. And the other option that you have is that you use something like a web worker. So not a service worker, that's another kind of a worker, but a web worker, which gives you another thread and another execution context for JavaScript. However, that doesn't have access to the full document object model either, and so therefore rendering will be kind of a problem. And this, of course, is not an ideal solution. There are, well, let's say, solutions on the way in form of the Realm specification, but it's, I mean, I don't want to say I've given up hope, but it's been now, I think, 6 years since we're talking about it, and it hasn't moved on, yeah, let's say, visibly. It moved on a bit, but it is, I mean, far away from being implemented in some browser. But I'm always, let's say, optimistic that at some point suddenly it's in Chrome, and then, of course, other browsers will follow. Nevertheless, injection, when I talk here about, what is our number one point? It's server-side. So let's say we are running a server-side composition from a Node.js application, and of course, we bring in the microfrontends directly now on the server side. And they will render and they will spit out, and we are all fine. But now, of course, we have a problem because now we have an injection in the browser, in Node.js, and unlike in the browser, there are not so many nice checks like integrity. Sure, we can implement them ourselves when we fetch the remote sources. We also make sure that we use some integrity flags. But even though that, let's say, safeguards a little bit, it doesn't safeguard that the script we're injecting has been malicious already from the point of publishing. Maybe there has been a vulnerability in the NPM packages that have been used to create that script, right? You don't know. I mean, again, you don't own these other repositories. Now, that might have access to anything like database connections or any kind of environment variables, and that's bad. So what can we do? Well, we can just not evaluate the module and evaluate it via, for instance, new function or require just. What we want to do is we want to sandbox that. And for this, there's a really nice thing in Node.js. It's called the VM module, so virtual machine, and essentially it allows us to restrict the access to the provided globals. So essentially all the runtime context. Now, an example, I think, is better than 1,000 words here. So let's see how this looks like. So this is some code that you might want to use in an altered form. So what we need definitely from VM is create context and run in context. Create context creates a new evaluation context, and run in context then runs some source code here given in form of content, whatever is in there, and evaluates that, right? And we can then even specify certain things like a file name that we want to give that is very useful for error messages, or even a timeout, which is quite nice because we don't want to let some script that we just got, let's say, drain the server resources and run for, I don't know, 40 seconds or longer than a request takes. So therefore, we really want to constrain this, and maybe even more than what we see here. 2 seconds is already quite some time, but There might be some asynchronous processes in there, so yeah, let's just give it 2 seconds. But we want to constrain that for sure. Now, what we give here is, on the first part, we give it some context information. Like, for instance, standard global module global variables like file name and tier name, you would give it, maybe it uses that, well, then it has it. And then you might also want to define how process looks like. And you might not want to give it the full environment variables like is given here. So env colon process env, you might not want to do, because this might contain sensitive information. You might want to give it over if you removed all the sensitive information. That you could do, of course. And this is fully up to you. Now, the next thing you want to give in is, of course, some kind of available API. Most notably, some globals that are always there, buffer, JSON. These things that are expected to be there and working from the JavaScript runtime, you want to pass in. Depending on what it is, you might want to modify it. And then finally, you might want to give it a require function. Now, you could give it the original require, but then the whole sandbox model would be broken a bit, because, I mean, now you got access to anything, right? So you can require a process, so child process, and run any kind of process, including reading out the original environment variables. You could require FS and read from the file system. So this is something you may not want to do. Instead, that's why I denoted here custom require. You might want to run it with something where you safeguard it. So certain things might still be allowed, I mean, depending on what is the name of the module, especially internal modules, maybe coming from the same microfrontend. You should just read them out and it's all good. But then again, in general, you might not want to give it access to anything. So FS or any kind of third-party dependency that you have installed, you shouldn't give access to here. And finally, we just put in the module, exporting module in there to get rid of that. All right, so there are 2 more things I want to discuss, but I will only touch them very briefly because they're web standards, and I just want to highlight how important it is that you actually respect them and have them really correctly used. So the first one, how are you, let's say again, treating third-party script injections, especially with ones like keylogger? We have already seen how we can safeguard against modification in our own code, but the mitigation that you definitely want to use still is in the browser is a really good content security policy definition. So this is done via some headers, and it will limit what scripts can do, from what sources they can come, and if, I don't know, they can be extended by themselves, for instance, via inline evaluations and things like that, right? And at the end of the day, this will limit arbitrary code, but also other resources on the client. In my opinion, this is very important. How it looks in general is that your users enter via the web browser your web page, and it sends back on the index HTML here in the metadata, but usually in the headers, a CSP rule, right? And this rule that contains now what sources, what origins are allowed, and I don't know, inline scripts and whatnot. What kind of scripts are allowed in general, but also other assets, images, style sheets, etc. Now, there is a possibility, and in my opinion, you should really do that, to also report violations of the policy. Quite often that violation is not, let's say, a really attack or something like that. It's really just, you didn't think of something, right? You're using, I don't know, a third-party dependency, and that also needs to load resources from another server. And now it's up to you to evaluate, do I want to keep that dependency? Can I maybe modify this URL? Or do I really want to allow this URL? But then again, you might not see this directly, and therefore having such a CSP reporting URL is quite cool. How you do it is like this. So you define the header, you give it a default source. This will be used now for all the assets if you don't, let's say, override it. Images, in this example, you'd say whatever, take it from anywhere. Same as media, audio, video, right? But then scripts, you might want to say, my scripts are all coming from userscriptsexample.com. Like microphone and assets example.com, and then only this source is allowed. but there's no inline scripts allowed, so no eval use or function or a script that has just text content in there is not allowed here, right? And this is quite crucial. And again, test your rules before you go. There is a special header called Content Security Policy Report Only. Set the policy, and then you can have a reporting endpoint, and therefore it will not put any errors. It will not block. It will just report these as warnings and report it to the endpoint additionally. The reporting endpoint is optional, in my opinion, really good if you want to first roll it out, let's say for a month to your end users, and then see what kind of violations came back, and then you can refine and iterate your rules. All right. Finally, attack vector in the misconfiguration space. You could send some authentication data from unwanted sites essentially, and therefore really open your services more than they should be. And it's a backend vulnerability, but you can also solve it in the backend by sending a certain set of headers known as cross-origin resource sharing or CORS. And this essentially will avoid all kinds of things, essentially also avoiding sending authentication data or other sensitive information, unwanted headers, if the site that's using it is from a foreign domain. Now, from a cookie perspective, that might anyway already be established if you use the same site policy. It might be not, depending on how your cookie is constructed. But then again, what you want to achieve is a behavior like this, where you say, okay, I'm now requesting from another server an image that should be just fine, and I allow that, and we're good. But then again, if request is made to some of my APIs, you don't want to allow that. So you're sending back a different set of CORS headers on the pre-flight request, which is the optional request that's sent from the browser always when there's a cross-origin request incoming, meaning from a different origin, you're sending a request. And so with this in mind, I wanted to leave some room for questions. That's why I hurried up a bit, and I hope we got some. Thanks everyone for the attention, and let's hear it for some questions.
Thank you so much for that, Florian. It was a really, really insightful session. I'm going to kick off the questions with a question that I have just on my own here. I was wondering, you've gone through a lot of different attack vectors from here on the micro front ends. I was wondering, is there a common security mistake that you see in lots of front ends, or is there something that is perhaps more predominant than the others in some of the subjects that you've covered?
I mean, I still would say, I mean, of course, this list wasn't taken out of nowhere. This I think covers it pretty much, but the number one is definitely the use of authentication tokens, right? I mean, sure, they're very helpful, and I'm also for simple web applications using them, but there is always a massive threat behind it. And I mean, luckily I wasn't, let's say, at least always in the room when problems were happening. But what I can tell you, when shit hit the fan, really, I mean, really literally even, the thing was in let's say 95% of the cases that a token was used and the token was sent somewhere else. And then suddenly, I mean, fortunately, it was always where the token went. Essentially, I mean, no one profited from that. But I mean, if someone would have wanted to profit, then really real user data could have been exposed, and a lot of worse things could have happened. So this is a very sensitive topic. These tokens are super powerful, and I would always try everything to guard around them, because if they go in the wrong hands, I mean, you're dead. And I mean, we are quite often, also as web developers, right? We are quite often just pasting these tokens somewhere in, right? So of course, these are usually quite nice pages like jwt.ms or .io, whatever them to just see our token decompose. But I mean, this is already also not very nice from a security perspective. So I would always say these tokens, they are so powerful and mighty, you might want to be very cautious about them. So this is the number one thing that I see being misused quite often.
Yeah, definitely, and it's great we say that, because so often in security we talk about very complex attack systems. We talk about very complex and sophisticated, supply chain attacks from state actors and all of that. And then when you look at the breaches that happen, half of them are they've bought a token from someone, or they've phished and they've gotten access credentials. And so we're still suffering from security basics. So I really relate to that.
Social engineering is the number one attack vector still, right? So I guess some responsible guy for security of a large company was asked, what does you make lose your sleep at night? And he responded, well, it's people. They click on everything in their emails, like everything. And I mean, these emails, they are, especially when they are targeted towards corporate users, they're quite often really well done, in my opinion. They're not like, as a private user, you often get these phishing emails where you can immediately say, I don't know, it's broken English, it's not even the real company's logo, or you always notice it, right? Usually. But the company ones, they are usually really well done, because, I mean, companies then actually send you these emails also. Last notification, you need to really log in now, and so, and they even make these trainings then where they say, well, if we send a very important message, that's probably spam, but then they still do it themselves. So it's really hard as a corporate, let's say, user or an employee there to distinguish one and the other. They're really well made, these phishing emails there, and so this is of course still the number one vector. They could just grab it. Of course, there must be still something else open, but it's social engineering always works.
Definitely. And developers are often targets of that. We don't have any questions from the audience coming through at the moment, so if you do have any questions, be quick to get them in here. Otherwise, we are going to release Florian back to the glorious town of Munich.
Thanks.
But I think we're finished here. So stay tuned in the security channel. We have another awesome talk coming up right after, which is going to be on building secure and flexible multi-cloud images with multi-boot mode. So Florian, I just want to give one final thanks for being here and sharing your knowledge with us, and finally, I see your LinkedIn down there. Is that the best place for the audience to connect with you if they want to perhaps follow more? So the LinkedIn link for Florian is down there. I'm sure if you just search his name, he will pop up. So Florian, thanks again for coming here, and wishing you all the best for the rest of the day.
You too. Bye.